Hello everyone, I am Kavya from Final Year CSC. Today I am going to discuss about the problem array's left rotation. Its difficulty level is easy and it was one of the standard problems which was asked in top product based companies like Amazon, Google, Microsoft, etc. So let's look at the problem. A left rotation operation on an array shifts each of the array's elements one unit to the left. For example, if two left rotations are performed on array 1, 2, 3, 4, 5, then the array would become 3, 4, 5, 1, 2. If you see here clearly, they are telling two rotations. If two rotations are performed, then our first two elements were moving at the end of the array, moving to the end of the array. Note that the lowest index item moves to the highest index in a rotation. Yes, because the element 1, which is at the lowest index, nothing but 0, now it is moving at the back of the array, nothing but like highest index. So this is called a circular array because all the elements were rotating in a circular manner. Right? And if you see the input output format, they have given the array size 5 and number of rotations that we need to perform. Here they have given 4. If we perform 4 rotations, our first 4 elements will move to the end of the array. So this is our result. The question says that we need to return an array, final array as the output. It should be like how it will be after performing those number of rotations. So I hope you understood the problem. Before getting into the solution, just pause the video and think for a minute. Hope you tried it. Let's look at the first approach. It was like a kind of brute force. And now I'm taking an array of size 7. Let's assume that. And now I have to perform 2 rotations. My final output should be like, it should be starting from 3, 4, 5, 6, 7. And then these first 2 elements should come at the end of the array. That's what my required output is. Now in the first step what I'm doing, I'm initializing a temporary array of size n, and I'm adding the elements from index 2 because a number of rotations that I need to perform are 2 except the first 2 elements, and these elements will be at the starting of my array, right? So I'm starting it from here and adding all the elements from second index to n-1. In my second step, I'm just adding the starting d elements at the end of the temporary, because I have already told you the starting d elements will add at the end of the array. So in my second step, I was doing that. Coming to the third step, nothing but I have already got my output, because if you see here, yes, the starting 2 elements now are at the end of the array. Now I'm just simply copying my temporary array into the original array. If you see the time complexity of this approach here, it was like iterating over n-d elements, because starting from d, traversing through the n elements, nothing but n-d elements. In the second step, just d elements, it was traversing. And in the third step, it was like traversing over n elements, because I'm just copying my temporary array into my original array. So it takes n steps. If you add all n-d plus d plus n, total 2n, nothing but O of n. Similarly, space complexity also O of n, because I am taking temporary array which is of size n. So my space complexity is also O of n. But is it necessary to take a temporary array which is of size n? Can't we optimize it? Can't we reduce our space complexity from O of n to O of n? Yes, we can reduce, we can optimize it. So how can we do that? Let's look at another approach. Here I am taking my array of size 6 and now I have to perform 3 number of rotations. What I am doing, just observe here clearly. I have taken the starting d elements. Because my d value is 3, so I am taking my starting d elements and I am reversing them. So I got 3, 2, 1. And now I am reversing the remaining elements 4, 5, 6. Now they became 6, 5, 4. If I reverse this whole array, see what I got. My output has 4, 5, 6, 1, 2, 3, which is my required output. It's simple. It's equal to my required output. See how simple it is. Here I am not even taking a temporary array as I took in the previous example. That means I am also saving the memory. Space complexity got reduced. Time complexity is has this. There it's a warp and here also, but space complexity got reduced. That means it's an optimal one, right? So let's implement this. Just reversing the starting D elements, and from D2 and minus 1 elements, and then I have to reverse my whole array. Let's write the reverse function. How can we reverse? For reversing, what I have to do? Reversing in the sense, I just need to swap the elements, the starting element and the ending element. If I swap them, and if I increment my lower boundary, if I decrement my upper boundary, it's going to be swapped. Incrementing lower boundary every time, and I'm decrementing my upper boundary. So let's try and see the output. Yes, my solution got accepted. Don't think this is only the solution. There will be different approaches, so you can try your own one. And hope you enjoyed it. If you have any queries, you can comment down. That's it for today. Thank you for watching.